Today we will discuss electron gun principle, construction and working. Electron gun is another device, very useful device, and work on the basis of acceleration of electrons by application of electric field, magnetic field, and has wide applications. Wherever we need electrons from many screens, television screens and other screens work on the same principle. In this lecture, you will learn basics about cathode rays, generation of cathode rays, positive rays, what are these rays, basic properties of these rays, fluorescent properties, shadow effects, and many others. You will study the Bethe law, which is similar to Snell's law in optics, and here is an analogy from the optics. We have developed Bethe law in electrostatics, or Bethe law for electrical for charged particles, then focusing of rays through lens, and finally we will discuss electron gun basics, principle, construction and working. Before starting the electron gun principle, we should know our basics. First is cathode rays. What are cathode rays? Cathode rays, clear from the name, emitted from cathode. The rays that emitted from cathode called cathode rays. A highly evacuated discharge tube. If we have a discharge tube basically a glass tube which is evacuated very highly with pressure 10 to the minus 4, 2 mm or 2 to the minus 3 mm. It is used for the production of cathode rays. We will discuss the figure in the next. But in this figure that is given here, you can see two electrodes, cathode, anode. Cathode electrode and anode. On cathode we apply minus side of the voltage. On anode we apply plus. Since anode is plus, positive, so the electrons from the cathode will eject out and move towards cathode. This ray, a beam, a stream is formed of electrons that is called cathode ray, which is emitted by cathode. Why we keep highly evacuated chamber? So that it cannot interact with others gaseous molecules. And here we have only those charged particles that we want to consider, that is electrons. For any electron gun or other devices, one thing is necessary, that you have to have stream of particles. So for here we will discuss electron acceleration, so electron beam is necessary. The electrons move from cathode and move towards anode very fast. But as these are the charged particles and having the same charge, so will repel each other. So forget about how obediently they will move in the same direction. they will rush towards the anode in a haphazard manner. These negatively charged cathode produce negatively charged electrons which accelerate towards anode as we have discussed, and this is termed as cathode rays, a beam of negatively charged electrons. You must note this. Some properties of cathode rays are emitted from cathode surface, and these are irrespective of position of anode. It means it is not depend on what is the position of anode, it was emitted from cathode rays. These rays travels in straight lines until and unless interact with others or in field of others. They cast shadows of object of which they fall. This is the same property as we already saw in light also. If you fall the cathode rays on any object, they will form a shadow. So it is used to analyze the images also. They produce heat on matter on which it falls. You can use for heating. They produce fluorescence. Another interesting property of materials. Some materials gives fluorescence. Fluorescence means emission of light even after, even in absence of any absorption, or even suppose you strike a beam on a surface, then immediately you will see emission. But if you stop the absorption, if you stop the incoming beam, and even after some time you will get some emission, that is delayed emission, that is called fluorescence. It is due to some internal process. They possess mechanical energy and hence mechanical pressure. They can penetrate through shell thickness of matter. Small thickness can be penetrated. They ionize the gas through which they pass. Ionization can be studied using this, because whenever it passes, if gaseous molecules can be ionized, then since it is a negative charge, it can ionize. Positive will be close to this and negative will be away from this. This can ionize. They affect photographic plate. If you have a photographic plate, as they form image also, so they can affect the photographic plates. They are deflected by electric and magnetic field, and when they strike on solid substance, they produce X-rays. Cathode rays also used for to generate X-rays. In all X-ray equipments, we have this electron cathode ray and electron gun. There is another ray that is called positive ray, opposite to that, canal ray or positive ray. And Goldstein, while investigating the cathode rays, he saw this interesting thing and designed a tube in which the positive rays emit from the anode and move towards cathode. In the setup for positive rays, a perforated cathode is kept in the between anode and fluorescent screen, as is seen in the figure. The electron emitted by the cathodes are accelerated towards the anode. On their way, they collide with the atoms of the gas in discharge tube. As a result, electrons are knocked out of the natural atoms and atom become positively charged. This is called ionization of gas. These ionized ions are accelerated towards the cathode, and some of the ion pass through the hole in the cathode and strike the fluorescent screen. It is thus seen that the positive rays are positively charged ions of gas contained in the discharge tube. As they pass through the canal of the cathode, as we have shown in the middle perforated cathode, so they pass from the through canal. They are also known as canal rays. Now this is the additional product of cathode rays emission. If we place in place of highly vacuum, if we place gas inside the discharge tube. The properties of these positive rays are they are deflected by electric and magnetic field. Obviously, charge streams are there. The deflection direction is opposite to cathode rays. Both have negative opposite charge, so deflection is opposite. They travel in a straight line. They produce phosphorescence and fluorescence. They affect photographic plates, can cause sputtering of metals. If it's very strong, if you strike on a metal, they can also sputter the metal, eject out the metal particles. And E by m, the ratio of charge to mass, is lesser than cathode rays due to higher mass of ions. And normally we use the term Q by m for positive. Q is the charge and m is the mass. The mass is very high as compared to electron of ions, so this value is very less. Electron gun basically deal by this law. This is the fundamental law, principle of deflection of electrons or any charged particle. Whenever a non-uniform electric field is we use, here non-uniform means the electric field varies point to point. An electron motion in such field can be explained on the basis of Bethe law. And according to Bethe law, all non-uniform field have equipotential surfaces. An equipotential surface is the surface where the electric potential remains constant and the electric field lines are perpendicular to the surface at any point. Any field is made up of non-uniform field. Suppose field is increasing from lower to higher, then we can consider the field consists of equipotential surfaces. Many equipotential surfaces are there and the field line is perpendicular to the surface. Just see this figure. Is it reminding you something? Yes, Snell's law. This Bethe law is similar to Snell's law in optics. We use Snell's law in optics to study the behavior of light wave in different mediums, denser and rarer mediums. Similarly, the Bethe has given law what happened when electron beam moves in non-uniform electric field. He considered this non-uniform electric field as consists of several equipotential regions. It may be thought that two metal surfaces charged to appropriate potential, and between these two surfaces A and B, electron is passing through equipotential surfaces. For allowing the passage of electron, we think electron will set up two closely metal surface grid as shown there, and electron is moving from one region to second region. The regions are equipotential. See the top side, electron is entering from one region, that is we termed as V1 potential, and moving towards the second region, that is V2 potential. In V1, suppose it is moving with velocity small v1, then it can be divided into two x and y components, dissolve into two components, vx and vy, v1x and vy. Similarly, after entering in the second, v2x and v2y, the angle with which the light is entering, I'm using term as I. On after the emission, when it's moved in the second region, I'm denoting that R. Reason 1 has potential V1 and 2 has potential V2 as we discussed, and the surface of equipotential surfaces. The velocity V1 alters into V2 as it moves from V1 to V2. We have resolved this also in X component and Y component. So whenever electron beam move from first to second, according to this Bethe law, there should be no change in X component. There should be change only in Y component, since we are saying the surfaces are equipotential. Equipotential means in X regions, I am assuming the potential is same, and potential is varying only in Y direction when you move from only in Y. So V1x should be equal to V2x. If we equate this using sin I and R, when we get this value, V1 sin I is equal to V2 sin R, and sin I upon sin R should be equal to V2 over V1. This law is similar to refractive index calculation in Snell's law. If V1 is greater than V2, then V1y increases. If V2 is greater than V1, then V2y is be more. In our case, V2 is greater than V1. As the electron move electric field, their kinetic energy is provided by potential energy, and so half mv1 square should be equal to qv1, or half mv2 square should be equal to qv2. Dividing these equations, you can get v1 square upon v2 square should be equal to v1 by v2, or v1 upon v2 should be equal to under root of v1 by v2. We have already calculated sin I upon sin r. So if you put this here, sin I upon sin r should be equal to v2 upon v1, or root of v2 by v1. This is known as Bethe law of electron refraction, and this is identical to Snell's law in optics. If we know the volt value of V1 and V2, we can check how electron will deflect. Electron lens can be made on the basis of this Bethe law, as we have already made optical lens, glass lens on the basis of Snell's law, using this property of equipotential surface. So why, let us know why we are discussing this here, because electron gun made up of electron lens. Electron lens is a main important part of electron gun. That is why we are discussing this. In electron lens, a stream of electron experience a change in direction of motion when it travels through non-uniform field. We use Bethe law here, and we have chosen the change in such a way through equipotential surface. Then this is analogous to refraction of light through lenses. The non-uniform magnetic field, electric field can be used as lenses to converge or diverge. For this, we create a medium. We have two cylinders, two coaxial cylinders of metals T1 and T2, and we put these cylinders coaxially separated by some distance. T1 is held at potential V1 or T2 has held potential V2 higher than V1. The non-uniform electric field is produced in the gap, and if you see the pattern, it is interesting to see that the pattern will be like lens, convex lens. Equipotentials are perpendicular to electric field everywhere. So if your cylinders are hollow, so whatever the potential is just at the corner of your cylinder, since it is hollow, the same field can be obtained just inside in the center. So there is a shape of convex lens. The scheme is shown here. We have V1 and V2. V1 is greater than V2, and equipotentials are shown here in the shape of convex lens. Electric field lines are already shown here, and equipotential surfaces are perpendicular to electric field. If the electrons are moving from left to right, they will converge due to bending, continuous bending at one point. Yes, this is the basic output of this electron lens. If you use electron lens and you pass electron through the cylinder, then due to this convex behavior of equipotential surface, all the electron will converge at a point that is called focal point. The working of the lens is shown here detail. We have already uploaded your notes also there. You can consult those notes. We have discussed this. A thin bundle of electrons rays entering the lens through tube T1. And for the sake of convenience, we have shown here 3 electron rays. Electron ray 1 through the axis and 2 or 3 off the axis. Electron ray on reaching the equipotential surface in the gap experience electric force along the axis. This is similar as the light ray passes through a lens. The light ray which passes through pole will experience a force only along that direction, same direction. This move without deviation. While the electron ray, which is 2, when reaching the equipment surface, acting on at an angle to the direction of their motion. The force experienced by the electrons at the convex equipotential surface perpendicular to axis. And because of this force, perpendicular force, the electrons are deflected down toward the axis, while the another force F parallel accelerate the forward. So it will move forward as well as downward side. However, on crossing the midplane of the gap, the electron encounter equipotential surface of convex shape. So this is directed away from the axis, while parallel is directed towards forward. As a result, the electron accelerate forward and tend to diverge. Thus, the first half of the lens acts as a converging lens, while the second half acts as a diverging lens. But then you can ask, if both are there, then why it is converging? It is converging because initially the velocity is small and it will live longer time in the first half as compared to second, because at the second velocity is higher. So the ultimate thing is convergence. For any set of voltage V1 and V2, the converging action is stronger than the diverging. Moreover, the electron travels slower in the first region. If slower means more impact. And the arrangement you can draw and think of. Read it again. So on the basis of this, we can design an electron gun. We have discussed Bethe law, we have discussed electron lenses, and these things we use here, electron gun. As it clear from the name gun, gun means something with very high velocity. Electron gun means a stream of electron which is highly focused and high velocity. It should be focused at one point. This produces a narrow electron beam of high intensity. It makes use of fact that the non-uniform electric field can be used to band and subtend focus electron rays. This electron gun is designed by V.K. Zoroikin in 1933, and the figure is shown here. First, as we have discussed, this is your cathode ray arrangement. This is a cathode. In the cathode we have a wire, tungsten or something. So we heat this and the cathode ray emit. This is thermionic emission. So cathode ray emit electrons. Now these electrons are crowded here. So we have used here this arrangement of several arrangement of these cylinders. This is your first arrangement of cylinder. Due to this, the electron get focused here at P. As we did the same in optical arrangements also. First we focus our light, then refocus again. Because there is a basic property of the good focusing is the source must be point. And cathode cannot be treated as point. So first we create the point P. Then from here we pass. This is first focal point. Then we use several anodes here. And again it will spread because it's a negatively charged, repel each other. Anything which is more angle will be absorbed with this slit and will pass through anode. This is second place where we focus the electrons. Electron move towards the screen from here. As it clear, these are the parts of electron gun: cathode, filament heater, grid, anode A1, A2. Cathode is a short hollow nickel cylinder and filament is enclosed inside it. The front face of cathode is coated with thiolated tungsten or beryllium or strontium oxide. The coating helps thermionic emission of electron at temperature 700 degree to 900 degree Celsius. The cathode is surrounded by the grid, which is negatively charged hollow metal cylinder or having a small aperture to allow electron. Now A1 and A2 beyond the grid we use to focus again, and we are increasing continuous potential. The whole assembly is kept in an evacuated space. Of course, a power supply provides necessary voltage here. When the power is turned on, the filament heat up. As the temperature characteristics of the cathode, the electrons are emitted through thermal emission. Now these electrons pass through the control grid. The grid is kept as a negative potential so that we will move in the only in the particular region electrons and control the number of electrons passing through it. The grid with a negative potential act as a gate and regulate the passage of current. The cathode, the grid, and the first anode constitute the first electron lens of the system. This lens is known as prefocusing lens. The electron emitted from the cathode tend to diverge because they repel each other. The convex equipotential surface bend the electron towards the axis. Consequently, all the electron converges at a point P just inside the surface. This point is known as crossover point. The electron emerging from P easily be focused on this point. The role of first lens is to converge the beam to the crossover point, which then act as a point source of electrons. The anode A1 and A2 from the second electron lens system, which draws electron from crossover point and bring them to fine point, and the diaphragm D we have used here as we discussed. This is used to stop wide angle electrons emerging from P. The focal point is controlled by adjusting the potential V1, A1 and A2. This is the detail. When electron gun is asked, what is the principle, what is the construction, and how it will work can be given. Thank you. In this lecture, we have studied rays, positive rays, negative rays, then how to guide these rays, means Bethe law, then electron lens, and finally electron gun and its working. Again, I emphasize all of you